Good evening. Please tell your friend to join. Please tell your friend to join. Yes, Rashito, good evening. Alko Prabhu, good evening. So today I am going to discuss intraclass correlation. In my previous class, we have considered the correlation between two clearly defined variables. Clearly defined variables means clearly defined variates. That is, for example, the marks of variable 1, marks in college exam, and another variable is marks in university exam. Yes, Sharnavo. Are you hear me? Any problem? I do not understand what you want to say. Are you hear me? Please tell me, how do you hear me? Hello? Yes. So please tell me, have you any trouble? Sharnavo? So marks in college exam and marks in university. Okay, thank you. Okay, Shashwat. Marks in college exam and marks in university exam for a group of students. Another example of clearly defined variable, that is percentage of family income spent on food. One is family income and another variable is percentage of family income spent on food. So these are the clearly defined variates. So in my previous class we have considered correlation. We have considered correlation between correlation between two clearly defined variables. This is called ordinary correlation. Okay, but here I think it is better to take example. Suppose we are investigating the correlation between heights of brothers and suppose there are two brothers in each family. If we take the height of the younger or the height of the younger brother or younger brother which is shorter than elder brother and height of the elder brother or and find correlation we would get the correlation between height of elder brother and height of younger brother or otherwise we can say or between height of because correlation coefficient always symmetry height of younger brother and height of older brother, or elder, height of elder brother. Okay. And this is simply as a correlation coefficient between these two variables. But in general, in family, there are more than two brothers. In that case, the question is to get the relationship between height of heights of brothers in general. So this is not a this case is not a simple, because now we have more than two brothers in each family. So in that situation, this is not a simple correlation or ordinary correlation coefficient. It is a different from simple and ordinary correlation coefficient. This is called intraclass correlation coefficient. So this is called intraclass correlation coefficient. So formally we define the intraclass correlation coefficient as intraclass correlation coefficient. There's sometimes arise cases in which we require the correlation with respect to a particular variate between members of the same class For example, with respect to marks in university examination, of student belonging to the same tutorial group or with respect to height of brother in the same family by correlation. Here we mean the extent to which the member the extent to which the members of the same class or group or family resemble each other with respect to the given variable. Such a correlation is called intra-class correlation. And intra means within the class. And so this ordinary correlation which we already learned in our previous class, we may call interclass. This means between class correlation. So this is the difference between ordinary or interclass correlation coefficient and intraclass. Intraclass means within the class we find correlation. Okay, so now we start with our problem. Suppose suppose xij denote the varied value for jth member of ith family. Okay, and suppose there are Suppose there are, I think it is better to write ki. Let ki is a number of brothers in ith family. Okay, and p is a number of family. Okay, so if you arrange this data in tabular form, then it should look like this is for family. For family 1, there are K1 brothers and their heights are x11. Suppose this radiate I consider height. In that case, x11 is the height of brother 1, and first one stand for family. So x11 is a brother 1 belonging to family 1. Heights of brother 1 belonging to family 1. Similarly, this is x12, height of second brother in family 1, third brother in family 1, and this is the n1th brother of family 1. Similarly, x21 is a height of first brother in family 2. This is the second brother of family 2. This is denoted by x22. So, and so on. And lastly, for kth family, should be okay. So we can arrange this data as follows. Now, so the UR, this is a mean which is nothing but a, first I define the variable. Suppose U stands for if we arbitrarily regard the first column of correlation table as correspond to as corresponding to a variate U, and the second column as corresponding to a variate V. Then mean of each variate is given by U bar. I denote this mean by U bar and V bar, capital U bar and V bar. Small U bar and V bar. It is better to write small U bar, V bar. So if you look at that table, then if you consider x11, then you see that actually correlation means pair of values. So if you consider family 1 and look at the first value x11, then you see that there are n1 minus 1 pairs, and these pairs forming with x11. Okay, if in the pair first element is x11 and second element can be filled by any n1 minus 1, any n1 minus 1 of this value. So this is true for all cases. So if you consider xij, that is the ith family, since there are, you can pair this xij with other element in ni minus 1 way. So this means is, if you add this thing, that is j from 1 to up to ni, sorry, this is not ni, please tell me, please rectify these things. I consider ki is a number of brothers. It is, instead of ki you write ni, then this should be ni, not ki. Okay, because I write these are n1, n2, np, so it is better to write ni instead of ki. Okay, please rectify this thing. So, and then sum of family means how many families are there? P. So for example, first I consider simply two family, okay, and there are, first family contain only two brothers, second family contain three brothers. Contain three brothers. So U bar means all possible, sum of all possible pairs. That means if you consider x11 pair with x12, and similarly x12 pair with x11, again x21 pair with x22, x21 pair with x23, x22 pair with x23. So it's better to write U. So U is x11, just write this one x11, x12, x21, first element of the pair. X1 appears 2 times, then automatically you write Vx12, this is x11, x21, when you consider x21 it should be x23, x22 and x23, and when you contain u is x22, this should be x21, x22, x23, x31, it should be x32 and x33, sorry, please change the notation. This is x23, then this should be x21, x23, x22. Okay, in the way we can define variable u and v. So obviously you see that u and v contain same number of variables, but the arrangement is different. So u bar should be, so please tell me, are you understand these things or not? Please tell me. Actually, correlation, if we want to formulate the correlation coefficient within the class. So for this we need to define two variables, because we want to use the correlation coefficient formula. So we need to define two variables. So correlation means correlation between two pairs. Actually, we want to find the height of relationship between height of brothers. So that means x11 is brother of x12. Height of x11 is a first, if you consider this is the first brother of family 1, this is the second brother of family 2. x12, again family 2, family 1, I call, okay, or I repeat, no problem. Actually, what is our problem? Actually, we investigate, I already told, we investigate the correlation between, for timing I consider height. You can take another variable also. For illustrative purpose, I consider height. Correlation between the heights of brothers. Okay, this is the problem. So heights of brothers, for here, for this example, this is the general arrangement. Suppose there are p family, the heights of brothers of each family we can arrange in that way. Are you agree? X, for example, x11 is a height of brother 1 of family 1, x12 is the height of brother 2 of family 1, x13 is the height of brother 3 of family 1, and so on. x21 is the height of brother 1 in family 2, x22 is the height of brother of family brother 2 of family 2, and so on. Okay, these are, in that way, can arrange. But since we want to find correlation between height of brothers means this should be a two pair value. This is suppose A and B. A and B are the heights of brothers. Suppose in family there are two brothers, 1 and 2. For this example, particular example, there are two brothers. The height of the brother, this can be paired as x11, one is a elder brother and 2 is a younger brother. This should be x11, x2. This is the pair elder and younger, and this is a younger and elder. All possible pair we consider. Similarly, if you consider second family, there are 3 brothers. So we can, there are 6 possible pairs because 3 factorial. We can arrange this as the 3 factorial ways. So it is a 6 possible pairs, and the pairs are x21, x22, x21, x23. See, all the brothers in every pair. If you look at the, we consider only the brothers of same family. Okay. So x21, x22, x21, x23. That means if I the brother 1 pair with brother 2, brother 1 pair with brother 3, then brother 2 pair with brother 1 in family 2, brother 2 pair with brother 3. Similarly, brother 3 pair with brother 3 pair with brother 1, and brother 3 pair with brother 2. So now I define variable. So before, suppose xij denote the variance value jth member, so it is better define, if we arbitrarily regard the first column of the before this, please write this sentence. Please write this sentence. It is better to write this sentence. If there are pi brothers in the family, there will be ki into ki minus 1 pairs. Thus, if we have p, if we have, so sorry, this is if there are ni brothers instead of ki ni. This is my mistake. Please rectify this thing because I consider ni brothers. It should be ni into ni minus 1. So please rectify this thing, not ki. It should be ni into ni minus 1. Thus, if we have p such families, there will be ni into ni minus 1, sum over ni into ni minus 1, I from 1 to p. Total number of pairs. So now we define u and variable v as, for this example, u, we write the pair as u comma v, then u is a first member of the pairs. That is, for this pair 1, 2, 3, 4, 5, 6, 7, 8. Okay. So we have for this example, particular example, where we only consider two families, and family 1 contains only two brothers, and family 2 contains only three brothers, then there are total number of pairs is 8. So u, and u is a first element of the pair. So for first pair, u is x11, v is x12. For second pair, u1 is a x12 and u is a x12 and v is x11. Similarly, for third pair, u is x21, x22, v is x22, and fourth pair it is again x21 is a u, v is x23, 5 for pair 5, x22 is a u, x21 is a v. For sixth pair, x22 is a u, v is a x23. For seventh pair, x23 is a u, x21 is a v. For eighth pair, x23 is a u and v is a x22. Okay, in that way you can arrange. Because we want to find correlation between heights of the brother. Okay, so we need to arrange this data in two variables u and v, because we know the correlation coefficient between two clearly defined variables. So we convert this data into two clearly defined variables. So next question, obvious question is, why sir considering x11, x12, x2, x1, x12, x11, these are the same thing, because you just consider the height of the brothers, because you consider the correlation between heights of the brothers. So why should consider permutation? It is enough if you consider combination. But if I consider combination, then u and v not equal. Number of elements of u and v are not equal. Or because if you look at this thing, just eliminate this part, then you see that every element does not appear exactly twice. Okay, so this is the problem. Moreover, the other way, that is, because we want to find the correlation between heights of the brother. Please listen carefully, because we want to find correlation between heights of the brother. That should be the relation between elder and if you consider elder first, then younger second, then we need to consider younger first, elder second, both pairs we need to consider. So in that way, we convert this data set, this whole data set, into two variable in that way. Okay. Now we are ready to apply correlation coefficient formula, which I already discussed. Already this formula is known. So please tell me, have you any problem? Or you mentioned that, please repeat, sir. Now you are satisfied. Are you satisfied with my explanation? If not, please tell me. I can again explain it more. I have no problem, or please tell me. Are you satisfied? Please tell me, are you satisfied? Reply quickly. Okay, thank you. Thank you. So, thank you also, Prabhu. So now if you look at this data set, first column of first column of correlation coefficient table, correlation table. This is called correlation table. This is called correlation table. This is called correlation table. So if you look at the first column of correlation table, then you see that U bar is, see carefully, x11 appear exactly 1 here, x12 exactly appear 1 here, but x21 appear twice, x22 appear twice, x23 appears twice, because it is obvious, because if you look at the procedure, then you see that we consider x11, in generally x11 pair with n1 can pair remaining brother, height of the brothers in n1 minus 1 ways, and for family 2 it is n2 minus 1 ways, and so on. So u bar should be summation j from 1 to j from 1 to ni, j from ni minus 1. So j from 1 to ni, it should be ni. Please write this thing, j from 1 to ni xij, sum over I from 1 to p, because there are p family. Okay, so you similarly we can find v bar, and we see that u bar and v bar are same. So please tell me, are you agree? So v bar are same. Please tell me, u bar and v. I got this thing, u bar equal to v bar, and it should be I from 1 to p, j from 1 to ni minus 1 xij. Are you agree with this thing? Please tell me. So now the next part, that is SU square, which is a standard, which is a variance, which is a variance of u. No problem. Please check yourself. The u bar equal to v bar equal to this. If it is, if you get this thing, it is okay. If you not getting this thing, please tell me. I will again explain this thing. Okay. So please take your time. In meanwhile, I discuss this part. Okay, no problem. You can comment. Comment. Uh, I will reply your doubt. Okay, on your doubt. So please check yourself whether this thing is correct or not. So SU squared, which is the variance of capital U, this should be 1 by n. N is the total number of observations, and n should be total number of pairs, that is ni into ni minus 1, sum over I from 1 to p. This is n, and xij minus x naught bar whole square. I denote this u bar equal to v bar by x naught bar, and j from 1 to ni. This is appears, the sum is appears ni minus 1 times. So, and since there are p families, so SU square is equal to 1 by n sum over I from 1 to p ni minus 1 sum over j from 1 to ni xij minus x naught bar whole square. Similarly, variance of SB square, variance of V, which is denoted by SB square, also 1 by L sum over I from 1 to p ni minus 1 j from 1 to ni xij minus x bar whole square. Okay. Now, SUV, which is a covariance between U comma V, is equal to 1 by n, that is xij minus, just I consider ith family and two member of this family, that is jj dash, xij minus x naught bar and xij dash minus x naught bar. Okay, and these appear exactly one, so j and j dash equal to 1 to capital Ni sum over, and since there are p family, sum over I from 1 to p. Okay. And this j should be not equal to j dash, because I consider two different family member of the same family. Okay. Now, sum over j not equal to j dash xij minus x naught bar xij dash minus x naught bar can be written as sum over j from 1 to ni xij minus x naught bar sum over j from j dash from 1 to ni xij dash minus x naught bar, since j dash not equal to j, so I subtract this portion xij minus x. So therefore, this portion is, this is equal to this, j dash equal to 1 to ni xij minus x naught bar minus j from 1 to ni xij minus x naught bar whole square. So this is equal to ni square xi naught bar minus x naught bar, and this is again xi naught bar minus x naught bar, this is whole square minus I j from 1 to ni xij minus x naught bar whole square, where xi naught bar is equal to 1 by ni sum over j from 1 to ni xij. Okay. So this means mean of x in the ith family. So therefore, SUV equal to 1 by n, 1 by capital N, sum over I from 1 to p, ni square, xi bar minus x naught bar whole square minus 1 by n sum over I from 1 to p sum over j from 1 to ni xij minus x naught bar whole square. So therefore, intraclass correlation coefficient is defined as R in suffix capital I for the intraclass correlation. Okay? Intraclass actually. So this is covariance between U comma V, SU is V. This is equal to SU is V, SU is V, which is equal to 1 by n sum over I from 1 to p ni square xi naught bar x naught bar whole square minus 1 by n sum over I from 1 to p sum over j from 1 to ni xij minus x naught bar whole square divided by, since SU is V are same thing, so it should be 1 by n sum over I from 1 to p j from 1 to ni minus 1 xij minus x naught bar whole square. So this is the intra-class correlation for the general case. Okay, for intra-class correlation coefficient for general case. Now, S square, which is equal to sum over I from 1 to, so before going to this, now consider special case where n1 equal to n2 equal to np equal to k. Then Ri equal to 1 by capital N I from 1 to p xi naught bar minus x naught bar whole square minus 1 by n I from 1 to p j from 1 to ni xij minus x naught bar whole square 1 by ni minus 1 means k minus 1 by n sum over I from 1 to p j from 1 to ni, not ni, this should be k, better to write k. So k, then it should be k xij minus x naught bar whole square. So now this covariance uv, which is when ni's are all equal, k square n is p into k into k minus 1 sum over I from 1 to p xi naught minus x naught bar whole square minus 1 by p into k minus 1 sum over I from 1 to p j from 1 to k xij minus x naught bar whole square xij minus x naught bar whole square, and where sm square, which is equal to 1 by p sum over I from 1 to p xi naught bar minus x naught bar whole square. So it should be k by k minus 1 sm square and s square, which is equal to one by p sorry, because there are total number of observation is n, so s square su square, since su square equal to sb square, I denote this by s square. So s square is 1 by n sum over I from, in that case, 1 by n k minus 1 sum over I from 1 to p j from 1 to k xij minus x naught bar whole square. So therefore this should be written as a, so this is a 1 by k minus 1 s square. Okay, so this is 1 by k minus 1 s square, and so therefore when ni's are equal, then ri is equal to k by k minus 1 sm square minus 1 by k minus 1 s square divided by s square. So therefore this is equal to k into k minus 1 sm square by s square minus 1 by k minus 1. So this is also true for general ni. So this is your homework. Please reduce this ri when ni's may not be equal to this formula k into k minus 1 sm square by s square minus 1 by k minus 1. So for general ni's where ni's are not equal. So this is your homework. Now s square which is equal to 1 by pk sum over I from 1 to p j from 1 to k xij minus x bar whole square, can write this as xij minus x naught bar whole square. We can write this as pk sum over I from 1 to p j from 1 to k xij minus xi naught bar whole square plus 1 by pk sum over I from p k into xi bar minus x naught bar whole square. Xi naught bar minus x naught bar whole square. And cross product vanishes still. Cross product term vanishes. Please check this. We write first. You write this thing as xij minus xi naught bar plus xi naught bar minus x naught bar whole square. Now break this whole square into two parts, and then you get this expression. Okay, and therefore SC square, which is equal to 1 by pk summation I from 1 to p, j from 1 to k, xij minus xi Traduction, please explain again from SUB. Which is your problem? Actually, SUB covariance between U and V. If you look at that, just consider you can write U and V two variables, values of the two variables, and take the covariance between these two variables. Okay. Then you see that we can write this formula as in that way. J not equal to J dash because we consider only the permutation part. So within a family, there are xij minus x naught bar, xij dash minus. Actually, if you consider the ith family, then look at J can pair only J dash. If you look at the ith family, there are and consider two brothers J and J dash, then J only can pair with J dash only once. Okay, so and since I consider permutation, that's why I write J not equal to J dash. In a way, you get both things xij, xij J dash, again xij dash, xij. So just look at the thing carefully. I already told you how to write U and V. Then simply think about how to compute covariance between U and V. Covariance, you know the formula covariance is for U and V. If you write in terms of U and V, then it should be summation I from 1 to capital N Ui minus U bar, Vi minus V bar. You know U bar is x naught bar, V bar is also x naught bar. So Ui minus x naught bar, Vi minus x naught bar, because U bar and V bar both are same. Now think about Ui and Vi. What do you mean by Ui and Vi? Ui is nothing but Xij, Vi again Xij. But think about the pair. Then automatically you reduce this formula 1 by n sum over I from 1 to p, sum over j not equal to j dash I xij minus xi x naught bar into xij dash minus x naught. Take a simple example for sake of simplicity. Just consider 3 classes or two classes. First you consider two classes, then three classes, and just take ni 2, 2, 3, n1 equal to 2, n2 equal to 2, n3 equal to 3, and for if you consider two classes, n1 2, n2 3, then you see that you get same formula. Then you can generalize this thing. Okay, so please try it yourself, and if you have a speed problem, then tell me. I will again explain this thing. So in a way, we compute this covariance between U, V. So Shayok, are you happy with him? Please tell me. Shayok, please tell me. Shayok, I'm telling you, please tell me, are you satisfied with him? Can you do yourself now? So SU squared, this is equal to xij minus, okay, thank you. X naught bar, this should be xij x naught bar. Okay, okay. Rectify this thing. Is equal to plus SM. And if you look at the expression, this is nothing but a sum of square within. This is nothing but a sum of square within groups and divided by, and that divided by pk. So for this reason we write this part by sw square plus sm square. So sw square equal to 1 by pk sum over I from p, j from 1 to k, xij minus xi naught bar whole square. So clearly, so both are sum of square, that means both are positive quantity. That it is better to say non-negative quantity. So for this reason, Sm square should be less than equal to S square, and therefore Sm square by S square, this should be less than equal to 1, and minus 1 if you multiply it by k Sm square by S square minus 1, this should be this. And if you look at the formula, this Ri, so this is nothing but Ri. So okay, so this means Ri lies between closed interval -1 by k minus 1 1. But we know for ordinary correlation coefficient lies between -1 to 1, but here we see that intraclass correlation coefficient lies between -1 by k minus 1 to 1, and we note that When k equal to 2, in that case Ri lies between +1 to -1. So from here, and Ri equal to +1, this means what? This means s square. If you look at this, s square equal to sm square. This implies hw square equal to 0. This implies this is nothing but a sum of squares and this implies xij equal to xi bar for all j from 1 to k, because I consider all family sizes are same and it is equal to, these are equal to k. And what is the interpretation of this? This means heights of brothers of ith family. If you consider the variance is height, then the heights of the brothers of the ith family are all same and these are equal to xi bar. This is the interpretation. And Ri equal to minus k minus 1, this means sm square would be 0. That means sum over j I from sum over I from 1 to p xi naught bar minus x naught bar whole square equal to 0. This means xi bar is equal to x naught bar for all I. That means ith family means are all equal, and which is equal to the grand mean. And this is the interpretation of the case 1, that is Ri equal to 1. This means the variance within families is 0. And ultimately this means variate values within each family are all equal. And this is sm square equal to 0. This means the variance between families between families is 0. And this means there is no variability between family members. note that as Ri lies between this, the lower limit is minus 1 by k minus 1, which is larger than minus 1, except k equal to 2, the lower limit also varies with varying k. Hence, the hence it is Q coefficient, that is not symmetry. For example, if k equal to 5, that is the family contain only 5 brothers, in that case Ri should be lies between 1 by 4 less than equal to Ri less than equal to 1. Hence, Ri equal to minus 1 by 4 imply there is a minimum intra-class correlation and which is this. Whereas Ri equal to plus 1 by 4 means this is there is a positive low intraclass correlation, low intraclass correlation, since maximum value of Ri is plus 1. So that is the reason Ri is not symmetric in general, symmetric only when k equal to 2. Because if you look at the negative part, for this example, k equal to 5, you see that Ri equal to 1 minus 1 by 4 is the lowest value, that is the minimum correlation coefficient, that is -1 by 4. If it is symmetric, it means 1 by 4 should be the maximum correlation coefficient, but the fact is this is not the maximum. It is a low positive correlation coefficient, and the maximum correlation coefficient is +1. So this is the reason we say that correlation coefficient is skewed coefficient and is not symmetric. That means it is not symmetric. Okay. And we already told what is the difference between intraclass because this is not a interclass we already discussed. This is a ordinary correlation coefficient, and it is a intra because we consider more than two numbers in each family. So this is not a interclass or ordinary class. This is called intraclass correlation coefficient. So now consider an example. Can I rub this portion? Please tell me. Have you any trouble? Also tell me. And if not, please tell me, can I rub this portion? Please tell me, can I rub this portion? Okay, thank you. So the weight in gram of a number of copper wire each of length 1 meter whereafter. These are shown below, classified accordingly, according to, classified according to the dye from each cup, dye from which they come. The data set as follows. 1.36, 1.35, 1.30, 1.35, 1.33, 1.34, 1.34, 1.32, sorry, 1.29, 1.31, 1.28, 1.31, 1.29, 1.33, 1.31, and the last is 1.30, 1.32, 1.33, 1.33. So we know to find intraclass correlation coefficient. All right. So we know the interclass correlation coefficient is invariant. That means unchanged under a change of base and scale, or origin and scale. And let us new variable be u minus hundred into x minus 1.28, where x is original variable. This means uij equal to 100 minus 100 into xij minus 1.28. So then the values are direct number 1, 2, 3, 4, 5, and then in respect of uij, these values are 5, 4, 8, 7, 2, 7, 5, 6, 4, 1, 3, 0, 3, 1, 5, 3, 2, 4, 5, 5, and totals, column totals are 24, 20, 8, 12, 16. So u bar, this is equal to 80. Just add all the values. If you look at the formula of u bar, which is equal to, because now it is now the size are same, family size are same, then u bar equal to 1 by pk sum over I from 1 to p, j from 1 to k, uij. So this is nothing but a grand mean, and grand mean is 80, and p is here 5 and k is here 4. So 5 into 4 is 20. So it is equal to 4. U bar equal to 4. And similarly, SU square, which is 1 by 20 sum over I from 1 to 5, j from 1 to 4, uij minus u bar whole square. These are the uij, u11, u12, u13, u14, and so on. So this value is equal to 4.4 sm square 1 by 5 sum over I from 1 to 5 ui bar minus u bar whole square. So u bar here is 24 by u1 bar 24 by 4, that means 6, u2 bar is 8 by 4, that is 2, and so on. u3 bar is equal to 12 by 4, this is 3, u4 bar equal to 16 by 4, that is equal to 4. So you using these values, you get Sm square is nothing but a 2, and hence Ri equal to 1 by k minus 1, k into Sm square by S square minus 1, after replacing the value of Sm square by 2 and S square by 4.4, then you get this value is 0.273. This indicates an interpretation of this value. This indicates that the copper wires coming from the same die reasonably resemble each other, same die resemble each other in respect of their weights only to a moderated degree. Only to a moderate degree. So some homework for each of 6 families, the heights in inches of 3 brothers belonging to it are recorded below. Compute the correlation of compute the coefficient of intraclass correlation. Intraclass correlation. The data is as follows. family. Here we consider 6 family, 1, 2, 3, 4, 5, and 6. And heights of brothers 69.5, 70.6, 72.3, 71.2, 70.8, 72.0, 65.6, 62.2, 68.0, 64.4, 67.2, 63.6, 70.5, 64.3, 66.7, 63.5, 70.5, 61.6. And the last homework is the birth weight of babies born to 5 mothers in a Calcutta nursing home are given below. Compute the intraclass correlation this is the mother and mother 1, mother 2, mother 3, mother 4, mother 5. So 6 LB 3OZ, 6 LB 8OZ, 6 LB 0OZ, 7 LB 9OZ, 8 LB 2OZ, 5 LB 10OZ, 6 LB 2OZ, 6 LB 4OZ, 6 LB 4OZ, 8 LB 6OZ, 7 LB 10OZ, 7 LB 5OZ, 6 LB 9OZ, last 6 LB 6OZ. Please do this and submit. Okay, and the last point I'm telling you, this is actually this intraclass correlation used in very much used in medical science. Okay, so it is this class very much helpful who are doing research in medical science. Okay, they can follow, if they can follow this class, they definitely help from this. Okay, so that's why I note this thing. This is the Sarko Prabhu. This is the ending note. In biological science situations, actually in biological situation, this type of situation arises. Okay, so if you have any doubts and queries, please tell me. Before ending this class, please tell me if you have any doubt. So please tell me, have you any problem or difficulty? I will explain you. Otherwise, I end the screen. Okay. In my next class, I am going to discuss multi, multiple regression. Okay. And on Tuesday, hopefully, and same time, 6 p.m. Thank you. Okay. Thank you. Thank you, everybody.